U.S. has again demonstrated its dominance in the skies. The U.S. next-generation Tiltrotor aircraft is now ready for action. This state-of-the-art aircraft has been designed to meet the demanding requirements of the Future Long-Range Assault Aircraft program. With the Tiltrotor, the U.S. Army has taken a significant leap forward in terms of its capabilities. The Bell V-280 Valor has been selected to replace the venerable UH-60 Black Hawk helicopter as part of the U.S. military's Future Vertical Lift program. It is the clear choice for the Army, offering unmatched capabilities and performance in lower-tier air domains. With the speed and range of a turboprop aircraft and the agility of a traditional helicopter, the V-280 Valor gives the military greater flexibility and maneuverability on the battlefield. Could this be the reason to retire the old helicopters and embrace the future of Tiltrotor technology? Join us as we explore how the V-280 is coming. Get ready for the next generation aircraft. Despite advancements in aviation technology, many of the aircraft used by the U.S. military are long overdue for replacement. The U.S. has recognized the need for a new generation of aircraft and helicopters that can operate in dangerous environments. It has prioritized the development of these new platforms, known as Future Vertical Lift. It aims to create paradigm-changing aircraft to revolutionize military aviation and its approach. By focusing on these long-term solutions, they seek to ensure that the U.S. military remains at the forefront of aviation technology in the decades to come. For more than 40 years, the UH-60 Black Hawk airframe has been the backbone of the Army's medium assault helicopter fleet, replacing the UH-1 Iroquois from the Vietnam War era. The UH-60A Black Hawk first saw action in the 1983 invasion of Grenada, and since then, it has played a crucial role in every conflict. The most commonly used modern version, the UH-60M, can carry up to 11 troops at a cruising speed of 142 knots, equivalent to 163 miles per hour, for distances up to 225 miles, with a self-deployment range of 1,070 miles. So the U.S. took advantage of the latest aviation technologies. They created the Future Long-Range Assault Aircraft, FLRAA, a program which aims to replace the UH-60 Black Hawk helicopter with a new design that may not even be a helicopter. Thus, they awarded Bell Textron a contract with a total ceiling of $1.3 billion to develop the replacement helicopter. After months of waiting for a decision, the competition to create the Future Long-Range Assault Aircraft, FLRAA, a vital part of the Army's plan to modernize its aviation platforms, has been won by the V-280 Valor Tiltrotor, beating out the Defiant X coaxial rotor blade platform developed by Sikorsky-Boeing. Bell has been granted an initial obligation of $232 million over the next 19 months to fund the preliminary design and development of a virtual prototype that the Army will use to proceed with the acquisition, paving the way for the future of aviation. At the outset of the acquisition process, no aircraft was procured, and the competition entailed two different approaches competing against each other. The first candidate was Bell Textron's V-280 Valor Tiltrotor design, which shared several similarities with the V-22 Osprey aircraft that the Marines, Special Operators, and the Navy flew. The V-280 Valor Tiltrotor design leverages advanced technology, such as fly-by-wire controls and a wide-ranging speed envelope, to provide an agile and efficient flight experience. The second candidate, the Sikorsky-Boeing SB-1 Defiant, was a more traditional helicopter-style aircraft that featured two coaxial main rotor blades stacked on each other and a rear push propeller. This design offered superior maneuverability and speed to meet the demands of modern combat missions. The competition between the two designs was fierce, with each offering unique advantages that could help it secure the acquisition contract. The V-280 Tiltrotor aircraft won the FLRAA program, which is designed to replace the UH-60 Black Hawk helicopter. It is built on a tiltrotor design. It takes off, lands with its propellers tilted upward like a helicopter, and then rotates them 90 degrees to a forward position, like a traditional propeller-driven fixed-wing aircraft. This unique feature allows the V-280 to take off and land vertically, like a helicopter, while also providing the benefits of increased speed and fuel efficiency of a fixed-wing craft, making it highly versatile and suitable for a wide range of military operations. The initial contract awarded for the V-280 program is focused on refining the weapon system design, sustainment, digital enterprise, manufacturing, systems integration, flight testing, and airworthiness qualification. This means that the V-280 will undergo rigorous testing and evaluation to ensure that it meets all safety and performance requirements before being deployed for military use. The program is expected to develop a highly advanced and capable aircraft that will provide the U.S. with a significant tactical advantage on the battlefield. The U.S.'s Future Long-Range Assault Aircraft, FLRAA competition, is a highly anticipated event that has attracted several companies, including Bell. The company has submitted the V-280 Valor, a tilt-rotor aircraft that meets the Army's long-term reliability and sustainability requirements. The total award amount for the FLRAA contract, which includes the engineering, manufacturing, and development phase, and the first lot of low-rate initial production, is estimated to be $7.1 billion. However, this is just the beginning of a much larger potential opportunity, which could be worth up to $70 billion, depending on the number of aircraft the Army procures over the long term, including potential foreign military sales. To ensure its platform's long-term upgradability and sustainability, Bell's engineers have adopted a forward-thinking strategy that utilizes the Modular Open Systems Architecture, MOSA. This approach involves using common technical standards, internet protocols, and specific interfaces that improve interoperability, making integrating new technologies and upgrading existing ones easier. By adopting MOSA, Bell is confident that the V-280 Valor will meet evolving needs and remain a reliable and effective platform for years. One of the most critical components of aircraft design is the MOSA, which stands for Modular Open Systems Approach. MOSA is so important because it enables the aircraft to stay operational well into the future, even beyond the 2030s. This is achieved by introducing next-generation technologies such as speed, range, agility, weapons, sensors, and computing, which are intended to break performance barriers and offer capabilities far superior to those of a Black Hawk helicopter without refueling. It is not enough to introduce these technologies, however. They must be sustained and upgraded over decades to come. This is where MOSA comes in, specifically designed to keep pace with emerging concerns around survivability and sustainability. As adversaries acquire more range, precision, jamming capabilities, and cyber war technologies, this approach aims to ensure long-term safety for the aircraft and its crew by staying entirely in front of these emerging concerns. Bell engineers adopted the MOSA to enable the V-280 helicopter to upgrade its electronics, computing, command and control, and aircraft survivability equipment, AS, at the speed of relevance. It is a cutting-edge technology that allows Bell engineers to upgrade the helicopter's systems in real time, ensuring that the platform remains relevant and up-to-date with the latest technological advancements. With MOSA, Bell engineers can upgrade the helicopter systems without being constrained by proprietary vendor technologies or the need to use bolt-on fixes requiring reconfigured hardware. This means new hardware configurations do not need to be built from scratch or integrated with an existing high-tech system. Instead, common standards applications are used, emphasizing ensuring connectivity and transport layers. These applications are hardened, speeding up the time frame for crucial upgrades and ensuring sustained interoperability and protection. To ensure long-term reliability for the V-280 Valor, Bell engineers completely deconstructed the aircraft, which helped solidify its MOSA strategy. By using MOSA, they can upgrade the helicopter systems to ensure reliability and performance and an ability to counter advanced enemy surface-to-air missiles. This vastly improves survivability by preventing in-flight malfunctions or mission failure during combat. MOSA is a game-changing technology that enables the V-280 Valor to remain at the forefront of helicopter technology. Also, the MOSA approach uses common internet protocols, interfaces, and data standards to facilitate the swift and low-risk integration of upgrades and sustainment enhancements. These upgrades may include software upgrades or modifications to the electronics, mission systems, or command and control. The pace of modernization, especially in computer processing, artificial intelligence, and sensor technologies, is accelerating at an unprecedented rate. As a result, Bell engineers deliberately designed the new V-280 with a technical infrastructure that would ensure long-term upgradability and reliability. However, the MOSA design not only guarantees the successful modernization of the aircraft, but also significantly enhances its survivability by improving the reliability of its systems. The V-280 can remain a reliable and effective aircraft for many years by focusing on these critical elements. The MOSA design has resulted in a significant increase in the performance of the V-280 aircraft. The V-280 was given its name to reflect Bell's aim of meeting the Army's objective of achieving a cruising speed of 280 knots, which was approximately twice that of the UH-60. However, it surpassed this objective by reaching a top speed of 305 knots. Furthermore, the V-280 can transport up to 14 combat troops, which substantially improves over the UH-60's limit of 3. Additionally, it has a reported combat-loaded range of 500 to 800 nautical miles and a self-deployment range of 2,400 miles, which is twice the range of the Black Hawk helicopter in both cases. The improved speed and range of the V-280 will make the military's air assault forces more efficient and effective on the battlefield. With a faster aircraft, air assault troops will be able to reach their destinations much quicker, enabling them to seize the initiative from the enemy and maintain it. For instance, let's assume that U.S. troops travel in the V-280S and are 322 miles away from their objective. They can reach their destination within an hour with a flying speed of 280 knots or 322 mph. On the other hand, an enemy force comprising T-90 tanks and BMP-3 infantry fighting vehicles, and is also 322 miles away from the same objective, can only travel at 32 mph. As a result, the troops in the V-280 will reach their goal in 1 hour, while the enemy mechanized troops will take 10 hours to get there. The V-280 Tiltrotor aircraft boasts several benefits, one of which is the increased range it offers. This capability allows the V-280S to fly longer distances while requiring fewer forward arming and refueling points for refueling, which is highly advantageous in a combat situation. When faced with enemies that possess long-range weapons, such as the Russian BM-27 Uragan multiple-launch rocket system, the V-280S can be based farther to the rear, out of rocket range, while still being able to carry out missions. Additionally, the increased ferry range of the Tiltrotors enables them to undertake missions across vast distances, such as the South China Sea, where they can hop from one islet to another or travel across Europe. Moreover, the V-280 Tiltrotor can be optionally manned to suit the military's needs. In 2020, a test V-280 aircraft completed an entire flight profile from takeoff to landing, without a pilot's hands on the controls, demonstrating the Tiltrotor's autonomous capabilities. It is believed this autonomous flight technology will help maximize the number of missions the FLRAA can undertake. For example, the aircraft can fly mundane resupply missions independently, allowing the human crew to rest and be better prepared for more complex missions when required. Similarly, effective monitoring is crucial for ensuring the safety and longevity of the V280 Tiltrotor, which has many dynamic components, including the blade retraction mechanism, rotor hub, transmission and engine systems, and nacelle tilting mechanism. The HUMS, or Health and Usage Monitoring System, is a state-of-the-art system designed to monitor and analyze the health and performance of various critical components of an aircraft. The system comprises several subsystems, each crucial in ensuring the aircraft operates safely and efficiently. One of the most critical subsystems of the HUMS is the Engine Performance Assessment System, which continually monitors the engine's torque and temperatures of the inlet, compressor, combustor, turbine, and exhaust. This system ensures that the engine operates within safe limits and that deviations from the norm are flagged for further analysis. The HUMS tracks life-limited parts by cycles or hours, automatically informing pilots or ground crew when parts approach their life limit. The system is equipped with a suite of warning sensors and software with knowledge of mechanical components' physical and temporal limits, enabling real-time life cycle analysis. Thus, it can warn crews of system failures and predict potential failures. The HUMS continually monitors and compares sensor data to its database of potential risks and failure modes compiled during flight testing and certification. If the observed sensor data matches a pre-existing template for failure, the system alerts flight crews and creates a diagnostic report to be examined later by maintenance technicians. The HUMS has three main functions: health monitoring, usage monitoring, and maintenance interface. The health monitoring function has four main tasks: rotor track and balance, engine performance assessment, mechanical diagnostics, and flight data recording. The rotor tracker monitors variable diameter rotors and employs a suite of accelerometers to ensure continuous rotor track and balance. The Engine Performance Assessment System is a crucial component of the health monitoring system that keeps track of various parameters such as engine torque and temperatures of the inlet, compressor, combustor, turbine, and exhaust. This system ensures that the engine is continually operating safely and optimally. The Flight Data Recorder, FDR, linked to the main flight computer and communication system, is responsible for logging all control inputs from the cockpit, recording all pilot vocal commands, and diagnosing post-catastrophe evaluation. This recorder is an essential tool that helps analyze flight data to pinpoint the root cause of any issues that may arise. Furthermore, the health monitoring system incorporates a condition trending algorithm that analyzes incoming data from the usage monitoring system to predict potential problems before they occur. The usage monitoring system acts as a recorder and database for the rest of the HUMS and flight ground crews. This system provides time tracking and cycle counting for life-limited parts and records, critical events such as time spent above torque limits, and in-flight fault and warning system resets to reduce and prevent the likelihood of catastrophic failures. Another essential subsystem of the HUMS is the Mechanical Diagnostic System, which monitors various mechanical systems such as the rotor and drive shafts, gearboxes, and nacelle tilting devices. This system continuously collects data on the performance of these systems and alerts the flight crew if any issues are detected. In addition, the maintenance interface serves a dual purpose of maintenance and configuration management. It enables crews to monitor specific systems vulnerable to ambiguous problems closely. All the data generated by the HUMS is transmitted to the ground station unit, which archives a comprehensive record system for the aircraft. This system is a digital logbook for the airframe, engine, rotor, stress, fatigue, and all aircraft systems. Considering the persistent threat of missile attacks, one potential solution is for air assault forces to adopt a more conventional and safer role of dragoons, akin to the cavalrymen of the past. This would involve dismounting from V-280 helicopters several miles away from the objective, far beyond missile range, and approaching the target on foot. Although this may appear to be a regression in technological advancement, the safety of human lives is the top priority in any conflict. Despite the changing nature of warfare, the V-280's advantages as a fast and long-range transport still hold up. Arriving at an objective 9 hours before the enemy can provide a significant advantage, allowing troops ample time to set up defenses and prepare for any incoming attacks. Therefore, it is clear that the V-280 has a crucial role to play in modern warfare, but its use must be adapted to ensure the safety of all involved. Additionally, tiltrotor technology has been gaining popularity in the U.S. military, with the Marine Corps, Navy, and Air Force already flying versions of the V-22 Osprey. However, the Army had remained the only holdout until the development of the V-280. With the operational version of the V-280 set to complete the tiltrotor takeover of the U.S. military, the Pentagon may never purchase another conventionally configured helicopter again, except for the Coast Guard. Also, the advantages of tiltrotors are immense, as they combine the vertical takeoff and landing capabilities of helicopters with the speed and range of fixed-wing aircraft. As such, tiltrotors are highly versatile and can perform a wide range of missions, from cargo and troop transport to search and rescue operations. Interestingly, the V-280 Valor, as it is currently designated, will likely be renamed in accordance with the U.S. military tradition of naming helicopters after Native American tribes, with the support of the tribe the name is drawn from. The new name will be revealed in 2025 when the prototype aircraft is scheduled to fly. In summary, the ongoing war in Ukraine has had a significant impact on the use of helicopters in warfare, with a staggering total of 81 helicopters destroyed on both sides. The use of shoulder-fired air defense missiles, such as the FEM-92 Stinger, has made the front line too dangerous for aircraft, resulting in the need for air assault troops to rethink their approach. Therefore, the V-280's strengths come into question. Does the U.S. next-generation tiltrotor aircraft, which is ready for action, have what it takes to adapt to the changing role of the helicopter aircraft in modern warfare? Thanks for watching. While you're still here, click on the link on your screen to watch another of our interesting videos. See you there.